Hi, welcome back into Stat students. So today we're going to do another exercise. Today we're doing the last exercise we did was writing hypothesis for tests about a proportion. And today we are doing conditions for a z-test about a proportion. Okay. So what this does is we are trying to find the conditions for a z-test, right? We have a claim and we are testing using a z-test for a population proportion. And there are conditions that come with it, okay? There are conditions that come with it. And what are the three? There are actually three conditions. So let me write those out. So three conditions. Um, all right, that's okay. So conditions for a z-test, right? For a z-test, um, conditions for a z-test, right? For a population proportion. Okay, population proportion, which is P. Okay. Now, you might find those three, there are three actually, three conditions. Those three conditions are very, very similar to the to the confidence interval um, conditions, because the first one is random sample, right? Random sample, or is if it's SRS, right? So, um, or it says it's from a random experiment. So if it says a random sample, check. Second condition for a z-test, right? It's n times p greater equals to 10, and it has to satisfy n times 1 minus p greater equals to 10. So that condition, so this is the first question you should ask, is it random? Second question you need to ask is it the normal? Is the sampling distribution normal? Okay, so, and this is the normal conditions, right? N times p greater equals to 10, n times 1 minus p greater equals to 10. The third condition is it independent? Right? Is it independent? So what you need to do is you look for independence in the question. If they say that the samples, if they did not say that the samples are independent, so you need to do the 10% rule. So what does the 10% rule says? The 10% rule says that your sample size has to be less than or equals to zero point 0.1. All right, 10% is 0.1 of the population size. Okay, so what you do is when you divide both by 0.1 by 0.1, right, this goes away, this will go away. So your population, as long as your population is whatever the sample size divided by zero point 0.1, as long as it's reasonable to assume that the population is more than this number, then the 10% rule is satisfied. So let's dive in. So Abdullah is a quality control expert at a factory that paints car parts. He knows that the factory paints 20% of the parts with an error. He recommended a change in the painting process, and he wants to see if this error rate has changed. He takes a random sample of 30 of the 100 total parts, painted one day to test the hypothesis. So the null hypothesis here is p equals to zero point 0.2, right? The population proportion of parts with an error. So it's zero point 0.2 versus the alternate hypothesis is p, population proportion p is not equals to zero point 0.2, right? He just wants to know if there's a difference. It has changed. Okay, where P is the proportion of all parts that the factory painted with error that day. So which conditions for performing this type of test did Abdullah's sample meet? So did they say anything about random sample? So we know this is check, right? The data is a random sample from the population of interest. Now the next thing is interesting. We need to find, so your p here is zero point 0.2 and your random sample of 30. So I need to take 30 times it by zero point 0.2. And that is only 6, which is not more than 10. So I cannot click this, right? The normal condition was not satisfied. And so it takes a random sample of 30 of the 100 total pots painted. So the population is 100. So 10% of, 10% of 100 is 10. But they took a random sample of 30. So that random sample, the sample is actually more than 10% of the population size. So the individual observations cannot be considered independent. All right. So here this condition is not met because there are only 6 errors. We just found that 6 errors, right? Because this times this is 6, and it did not. It's not more than 10. So, and this condition is not met since he sampled without replacement, and the sample size exceeds 10% of the population. Okay. So if you look through this again, a restaurant chain wants to hire roughly the same proportion of men and women for entry level positions. Management took an SRS of 12 entry level hires from over 1,000 entry level hires in a recent month. So cool. We know it's random. So they want to use the sample data to test H naught. The null hypothesis is the population proportion equals to zero point 0.5, which is 50%, versus the alternate hypothesis, the population proportion is not equals to zero point 0.5. So it could be lower, it could be higher, but as long as it's not equals to, that's fine. Where P is the proportion of all entry levels of that month who were women. So 12, right? SRS of 12 entry level hires from over 1,000. So if I take 10%, 0.1 times 1,000, which is the population, 100, and I took 12. Yeah, okay. Since the sample was done without replacement, yeah, well, that works. Now, what is n? N is 12 times 0.5, right? P is 0.5. I only have 6, which is less than 10, so I cannot click this, right? I cannot click this. This condition is not met since there are only 6 successes and 6 failures, right? I only did 6 successes and 6 failures. This condition is met, we can assume independence since the sample was less than 10% of the population. So hopefully this makes sense. Let me know if you have any questions. Thank you very much.